Welcome to the 18th hole of the Adventure Golf Course. We're going to be looking at the volume of cones and pyramids today. The question, how does the volume of a cone compare to the volume of a cylinder?
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is a third of the volume of the cylinder.
If we know that the volume of the cone is a third of the volume of the cylinder, we can think about how we find the volume of a cylinder. Area of the base, pi times radius squared, times the height. That would give us the volume of the cylinder, and then if I divide by 3, that will tell me the volume of the cone because it's 1/3. Or I could take the area of the base, pi r squared, times the height, which gives me the volume of the cylinder, and then I could multiply by 1/3. So 2 different ways. I personally prefer to divide by 3 rather than deal with a fraction. So area of the base times the height gives me the volume if it were actually a cylinder. Divide by 3 tells me the volume of the cone, because the volume of the cone is 1/3 the volume of the cylinder. Those two volumes, or those two formulas, would be the same because dividing by 3 and multiplying by the reciprocal, or 1/3, are exactly the same. What is the volume of each of the cones below? If we look at these cones, 3 different examples. The first example has, if I were looking at this as a actual cylinder, we'd have a radius of 5 and a height of 15. So I'm going to take pi times my radius squared times my height, and then I'm going to divide by 3. And with order of operations and the commutative property, I can actually deal with this last bit here first. So I could take pi times 5 squared times 5 if I would like, but if I'm punching it into a calculator anyways, which I likely am when I'm dealing with pi, I'm actually going to punch that in just straight across. Pi times 5 squared times 15 divided by 3. A rounded number would be 392.70, and this does not have units listed, so I'm going to just make it units cubed, or cubic units. 392.70. If I did this in terms of pi, I would have pi times 25 times 15 divided by 3. 5 squared is 25 times 15 times 3. Divided by 3 would be 125. So I'd actually end up with 125 pi. These two answers would be approximately equal. This would be my exact answer. This would be my rounded answer. Down here, pi times 3 squared times the height of 12 divided by 3 because it's a cone. Exact answer would be 3 squared is 9. 12 divided by 3 would be 4. 9 times 4 would be 36, would be 36 pi. Or if I just punch that into a calculator, pi times 3 squared times 12 divided by 3, 113.10 and it would be in cubic centimeters. And my third example on this page, down here, pi times 5 squared, that's my radius. That gives me the area of the base times the height, divided by 3 because it's a cone. I would end up with 25,250 divided by 3 times pi. Pi times 5 squared times 10 divided by 3 equals 261.80, and that would be in cubic centimeters. Area of the base times the height gives me the volume of the cylinder, and then it's a third of that, so I divide by 3. In this case, your problem is a little different because we have an actual cone on top of a cylinder. So pi times 5 squared times 13 . This is actually a different problem. 13 is the slant height. This is a Pythagorean triple, which tells us this height, the actual height here would be 12. It's a 5, 12, 13 triple. So I need to change this. The 13 was only used to give us the 12. Pi times 5 squared, pi times radius squared, times height, plus I need to find the volume of that cylinder. Pi times 5 squared times 2. Punch all that in. Pi times 5 squared times 12 plus pi 5 squared times 2 equals 1099.56. And this would be in cubic centimeters. And you can see this gives me the area of the base times the height is for this cone. If this cone were a cylinder, that would give me the volume. I actually forgot to divide by 3. So I need to take my answer that I had given you and divide by 3. This answer is actually incorrect. Pi times 5 squared times 12 divided by 3 plus pi times 5 squared times 2 is 366.52 centimeters cubed, or cubic centimeters. What would the volume of Newt soup would fit inside the witch's hat? It's got a height of 29 and a base of 15. So if this were a cylinder, it would be pi times, my radius would actually be 7.5. My diameter is 15 squared times the height, but because it's a cone, I must divide by 3. So pi times radius squared times the height divided by 3 equals 1,708 and 24 hundredths is a rounded answer. Centimeters cubed. So how do you find the volume of a pyramid? The same way that we found the volume of a cone. You find the volume of the prism and then divide by 3. So you look at the base of that pyramid and then the height of that pyramid, and you find act like that would have been a prism. Length times width times height divided by 3. Or if it's a triangular pyramid, it would be area of the base times height divided by 3. In this case, I've got my base is 36, 6 times 6, times my height, 15, divided by 3. 36 times 15 divided by 3 equals 180. And that would be in cubic meters. Down here, 8 times 10 times my height of 6 divided by 3 because it's a pyramid, and a pyramid is 1/3 of a prism. 8 times 10 times 6 divided by 3 is 160, and this would be in cubic inches. Volume is in cubic units. Here we'd have 4 times 10, area of the base, times the height of 6. That would give me the volume of the prism. But it's a pyramid, so I must divide by 3. 4 times 10 times 6 divided by 3 equals 80. And that would be in cubic centimeters. 4 times 4 times 9 divided by 3. 16 times 3 would be 48. Or I could just do 4 times 4 times 9 divided by 3. And I end up with 48 cubic centimeters. To summarize what you should have seen today, to find the volume of a cone, you take the area of the base of the cone, pi r squared, times the height of the cone, and then you divide by 3, or you can multiply by 1/3, and for the pyramid, you find the area of the base, multiply it by the height of the pyramid, and divide by 3. You're now ready to get online and print out the 18th hole scorecard.